All right, hello everybody and welcome. And this is Mrs. Masteller once again. And our last topic, well, not our last topic, but our second to last topic. Our last topic as far as solving a quadratic equation. So again, we've learned how to solve a quadratic equation by graphing. We've learned by factoring. We've learned by completing the square. And now our last and final way that you could solve a quadratic, which always works. So this is always a way to get to solutions, is by using the quadratic formula. So what is the quadratic formula, you ask? It is this. It is x equals negative b plus and minus the square root of b squared minus 4ac, and that is all over 2 times a. That's the quadratic formula. Okay, so all you have to do, formulas are pretty simple to use as long as you know what to plug in and where it goes. So as long as you can identify what a, b, and c are, and then just plug them in, it's all pretty simple from there. Okay, so let's start with the first one. We're going to solve this quadratic by using the quadratic formula. All right, but first thing you must do to properly identify a, b, and c is make sure that it says equals 0. So the fact that the 33 is on the other side, bring the 33 over to the other side, just subtract it. So our quadratic in standard form would be x squared minus 8x minus 33 equal to 0. Now we can go ahead and start plugging things in and getting to our final solution. Okay, so our a value, if you had to properly identify a would be 1, b is negative 8, and then c is negative 33. Okay, so using the quadratic again, it's x equals negative b plus and minus the square root of b squared minus 4ac, and it's all over 2 times a. So the more times you write out the quadratic formula, the more you're going to memorize it. Okay, so if you plug in these numbers where they go, starts off negative b is negative 8, so be negative negative 8. Plus and minus the square root of b squared, so negative 8 squared, minus 4 times a is 1, times c is negative 33. That's all over 2 times a, so 2 times 1 on the bottom. Okay, so we got it all plugged in. Now we just need to start calculating step by step here. All right, so first thing I'm going to do in my next step is I'm going to make this x equals positive 8, so negative 8 would be positive 8. Underneath the square root, negative 8 squared is positive 64. And then when you're multiplying, you're technically multiplying negative 4 times 1 times negative 33. So negative 4 times 1 is negative 4, and then negative 4 times negative 33 would be positive. So 4 times 33 is 132. 2 times 1 is obviously 2. Okay, so just step by step, we're going to work this thing down. Okay, our next line, I would probably go ahead and add underneath the radical. Add those two together. So 64 plus 132, that'd be 196. And this is all over 2. Next thing, take the square root of 196. So if you can simplify it, simplify the radical, the square root of 196. So what number times itself is 196? That'd be 14. Okay, so now we have to solve for our two solutions. So we're going to split it up at this point. Okay, so splitting up the whole plus and minus part. What you're doing, one answer is going to come from 8 plus 14 divided by 2, and then the other one's going to be 8 minus 14 divided by 2. So 8 plus 14, that's 22. Dividing that by 2, your first answer would be 11. 8 minus 14 would be negative 6. And negative 6 divided by 2, you get negative 3. All right, so there's your two solutions right there, positive 11, negative 3. So the solutions are x equals 11 and x equals negative 3. Keep in mind, once again, what do these answers mean to us? These two answers would represent, on a coordinate plane at negative 3 and at positive 11, our parabola is crossing over the x-axis. Okay, so at those 2 points, negative 3, positive 11, again, those would be our x-intercepts. All right? So number 2, look in the next one. So it's already equal to 0, so identifying a, b, and c, a would be 1, b is negative 34, c is 289. All right, so plugging into the quadratic, here we go. So starts off again, negative b, which would be negative negative 34, plus and minus the square root of b squared, so negative 34 squared, minus 4 times a is 1 times c is 289, and this is all over 2 times a, so 2 times 1 on the bottom. Okay, next thing. Negative negative 34, it's positive 34. Plus and minus underneath the square root, negative 34 squared, so negative 34 times negative 34 would be positive 1,156. And now negative 4 times 1 times 289 will be negative 1,156. 2 times 1 on the bottom would just be 2. Again, step by step, we're going to get this thing all the way solved through. So the next thing, underneath the radical, 1156 minus itself is obviously just 0. So we're going to have 34 plus and minus the square root of 0 over 2. Well, the square root of 0 is obviously just 0. So we're adding and subtracting 0 away from 34 and then dividing by 2. Well, think about it logically. If you add 0 to 34 or if you subtract 0 from 34, it's still going to be 34. So realistically, you're only going to get one answer in the end. Okay, so there's only going to be one solution to this problem. Again, if you want to split it up, you can. If you want to say, 34 plus 0 divided by 2, again, that's just going to be 34 divided by 2. Or if you were to say 34 minus 0 divided by 2, that's still going to be 34 divided by 2. So no matter which way you look at it, you're just taking 34, dividing it by 2, and your one and only solution would be 17 in this case. Okay, 34 divided by 2, you get 17. So again, what that would mean, graphically, our parabola would just be touching the x-axis at 17, just the vertex. It would be an upward-facing parabola because our a value is positive, but it would just be touching the x-axis again at that one and only spot. Okay, so it's not fully crossing over. It just comes down to the vertex, touches, goes back up the other side. All right, let's try a couple more. On to number 3. On to the next page. First thing again, set this thing equal to 0. So add the 2 to the other side. So you have negative 2x squared plus 2x plus 2 equals 0. All right, your a value is negative 2. Your b is positive 2, and your c is positive 2. If you wanted to, you can also reduce down this equation, because obviously 2, 2, and 2, you could divide everything by 2 and just say negative 1, positive 1, positive 1 for a, b, and c, but I'm just going to stick with what we got. Okay? So, plugging in these numbers where they go. So again, starting off, quadratic formula. Negative b, so negative 2, plus and minus square root, b squared minus 4 times a times c is all over 2 times a. But it is all plugged in. Okay, so we just plugged it in. Now start simplifying. So that's still going to be negative 2 plus and minus square root. So 2 squared, that's 4. Negative 4 times negative 2, that's 8. Times 2 is 16. This would be all over negative 4. Okay, let me erase that a little bit so it doesn't extend too far. So 4 plus 16 is to be negative 2 plus and minus square root of 20 over negative 4. The square root of 20 does simplify. So how would you break down 20? I would probably choose 4 times 5 because the square root of 4 is 2. And then you got the radical 5 left over. So now my next line is going to say we'd have negative 2 plus and minus 2 square root 5 all over negative 4. So again, 20 is not a perfect square, but you can at least simplify the radical to being 2 square root 5. Okay, technically we are done. Okay, you could leave your answer again all with a radical, leave it irrational just like the way it is, but you could reduce this down. If you notice, you have 2, you have 2, you have 4, all those numbers out front are divisible by 2. So you could take it a step further and then just simplify everything by 2, making this negative 1 plus and minus. This would be 1 square root 5 all over negative 2 in the bottom. Okay, and that'd be perfectly fine. All right, so your 2 answers in the end, just put them down here. Negative 1 plus and minus square root 5 all over negative 2. You can even, since these are both negative, both those leading numbers, you can also just say positive 1 plus and minus square root 5 all over positive 2 would be the same thing. Okay? And if you want to divide up your 2 solutions, you could do that. So if you want to write them out separately, but you can also just leave them combined as one solution. All right? The last one, number 4. So again, make sure it's equal to 0. You can either subtract the 2x squared. I think I'm going to subtract the 2x and then add the 5 to set this thing equal to 0. So 2x squared minus 2x plus 5 equals 0. And then my a value being 2, my b is negative 2, and then my c value would be 5. So plugging this in, we'd have x equals negative b, so it'd be negative negative 2, plus and minus the square root of b squared, so negative 2 squared, minus 4 times a times c. This is all over 2 times a. All right, we got it all plugged in. So now, again, start calculating. So this would now be positive 2 plus and minus square root. That's positive 4 for negative 2 squared. Negative 4 times 2 is negative 8. Times 5 is negative 40. This is all over 4 in the bottom. Okay, next thing, right next to it, I'm just going to say 2 plus and minus. Underneath the radical, that's negative 36 when you subtract. So 4 minus 40 is negative 36. But now that we're taking the square of a negative, we know it's going to be imaginary. So my next step, I'm going to call this 2 plus and minus. That would be 6i. Once you take the square of negative 36 all over 4. Okay, so again, technically we're done. You could leave your answer like this, again, as your imaginary solution, or take it one step further. Again, all these numbers you can see are divisible by 2, 2, 6, and 4. So writing out my final answer, I'm just going to call this 1 plus and minus 3i all over 2 as my two final solutions. So if you wanted to, again, I say 1 plus and minus 3i all over 2. If you want to write them out separately, you can also say it's 1 plus 3i divided by 2, and then 1 minus 3i divided by 2. It doesn't really matter. Okay, but you can also leave it combined all as one solution, like I said. If you want to write them out separately, you can, but you don't have to. Okay, so last thing we have to talk about, so now that we know the quadratic formula, the discriminant is now our next part. The cool thing about the discriminant is that it always kind of shows you what type of solutions you're going to have. So the discriminant is just basically the stuff that's underneath the radical in the quadratic formula, the b squared minus 4ac. That's the discriminant. Okay, again, it's going to tell you exactly what kind of solutions you're going to have altogether. So let's actually look down here. Let's look on the right-hand side first. So it says if you do b squared minus 4ac, and it comes out to be a positive number. So if it comes out to be a number bigger than 0 and b squared minus 4ac is also a perfect square, you're going to get two real rational solutions. So let me give you an example of that. Okay, I want to think of a positive number that's also a perfect square. So like 25, 49, 100, right? These are all positive numbers and they're perfect squares. Again, you will have two real rational solutions. What that's going to look like on a graph, so it might be a parabola facing up or down, but you'll see it actually cross over 2 times. Okay? Even if you do b squared minus 4ac and it comes out to be a positive number, but it's not a perfect square. So let me give you an example of that, like 26, 40, 55. These are all positive numbers, but they're not perfect squares. You would still see the same thing graphically. You would still see a parabola crossing over the x-axis in 2 spots. Okay, so where we can see examples of this. Let's go back here. The very first problem, take a look at your discriminant. Underneath the radical, this is what I'm looking at. This is the discriminant. So underneath the radical, you can see we're at 196. That is a positive number and it's a perfect square. And as you see, our answers came out to be real and rational solutions. 11 and negative 3, those are real numbers and they're rational. But let's look at example number 3. If you do b squared minus 4ac, if it comes out to be a positive number, but it's not a perfect square, like 20. 20 is a positive number, but it's not a perfect square. Okay, what you're going to end up with are two real but irrational solutions. Because my answer is still in radical form, that's technically an irrational answer. Okay, that's an irrational number. All right? So the next possibility is, what if we do b squared minus 4ac and it comes out to be exactly 0? You're only going to have one real rational solution then. So again, it'd have to be 0 when you do b squared minus 4ac. And that example was example number 2. Example 2, when we did b squared minus 4ac, check it out. Underneath the radical, it came out to be 0, right? Well, look, we only got one real rational solution in the end. That's it, 17. So if you do b squared minus 4ac and you get it only, or if you get 0, you're only going to have one real rational solution. And again, what that's going to look like, I already kind of mentioned it, it'd be a parabola either facing up or facing down, but it's just going to be touching the x-axis at that one solution. Okay? If you do b squared minus 4ac, so underneath the radical, if it comes out to be a negative number, you will have two complex solutions. So it doesn't matter if it's a negative perfect square like negative 16, or if it's like negative 121, or if it's negative, I don't know, 115. Okay, as long as that comes out to be a negative number, you will have two complex or two imaginary solutions in this case. What that looks like graphically is you're going to have a parabola either facing up or facing down, but it's not going to cross over the x-axis. Okay, so if it doesn't cross over the x-axis, technically there's no solution, but there's no real solution to the problem. But you're still going to have two complex solutions. So where we saw that example was the very last problem. So check it out. The very last problem that we did, when I did b squared minus 4ac underneath the radical, we got a negative number, negative 36, right? Well, in my answer, you can even see we got a complex number. Anytime you see I in your solution again, technically it's a complex number. Okay? So we're just going to identify. It says find the values of the discriminant and then describe. I want you to describe what kind of solutions would you have then. Okay, so if you just do the discriminant, if you just do b squared minus 4ac, that's the discriminant. What kind of solutions would each of these problems actually have? So if I do b squared minus 4ac for the first one, that'd be 6 squared minus 4 times 1 times 9. So that'd be 36 minus 4 times 1 is 4, times 9 is 36. We get 0. Okay, so that is my discriminant. What kind of solutions would I have then to this problem? Describe what kind of solutions. Well, if the discriminant comes out to be 0, you're only going to have one real rational solution in the end. So it'll be one real rational solution. All right. Let's try the next one. So b squared minus 4ac for b. This would be 3 squared minus 4 times 1 times 5. So that would be 9 minus 20, which would be negative 11. That's our discriminant. The fact that it came out negative means that you would have two complex solutions then. So it'd be two complex. All right. The next one, b squared minus 4ac. So if we do 8 squared minus 4 times 1 times negative 4, that's going to be 64 plus 16, which would be 80, and that's our discriminant. So 80 is a positive number, but it's not a perfect square. So if you actually take the square root of 80, you can simplify the square root of 80, but you can't actually take the square root of 80. It's not going to come out to be a nice, clean, solid answer. But this would give me then two real but irrational solutions then. I'd have two real irrational solutions if I were to continue through and actually solve the problem. Okay, and the very last one, if you do b squared minus 4ac, so if I do negative 11 squared minus 4 times 1 times 10, so that's going to be 121 minus 40, and that would just be 81. So that's my discriminant. Okay, 81 is a positive number, and it's also a perfect square, which means you would have then, so if it's positive and a perfect square, you would have two real but rational solutions then. So the type of solutions we would have to problem D would be two real and then rational solutions. Okay, so just by identifying the discriminant, you should be able, that's going to be your indicator as to what kind of solutions you can expect to have. Okay, whatever's underneath the radical, whatever you're taking the square root of, again, that will show you what type of solutions you'll have at the very end. Okay, there you go. There's the quadratic formula and the discriminant. So if you guys have any questions, as usual, let us know. Have a great day.